In this lesson, we'll finish learning target number 3. We're going to discuss how to prepare a solution by starting with a solid or by diluting a stock solution. In order to make a solution from a solid solute, you must first calculate the mass of solute needed to create the desired concentration. You can use your mole map or the equation C equals N over V and M equals M times big M. After you've done the math and you know the recipe, follow the procedure on page 384 on how to use a volumetric flask. This is the same procedure that you used during the molar concentration activity. When you buy some chemicals, they already come in solution form. These are known as standard or stock solutions. If you need a solution that is of less concentration than a standard solution, or one that you've made from a solid, you can perform a dilution. A dilution involves adding more solvent into the solution, which will decrease the concentration. In the space below, we'll derive a math equation specifically for doing dilutions. If we start off with a stock solution with a certain concentration, we'll call that C1. It's going to equal the number of moles of solute divided by the initial volume of the solution, V1. The solution that we want finished with we'll call the diluted solution. It will have a lower concentration than the stock. It will have some concentration, C2. It will equal the number of moles of solute divided by the final volume of diluted solution, V2. Now, since in a dilution we're only adding more solvent, the number of moles of solute doesn't change. Let's rearrange each of these equations so that it says N equals. For the stock solution, the moles of the solute is going to equal the concentration times the volume, and the same thing for the diluted solution. Because the moles are the same number, we can set C1 V1 equal to C2 times V2. This is known as the dilution equation. It's really important to note that we can only use this equation for diluting substances, not for changing one chemical into another. This equation does not take into account the mole ratios that are required to do chemical conversions using stoichiometry. Let's do a couple of examples. You add water to 25 mL of 12 mole per liter hydrochloric acid. If the final volume is 150 mL, what's the final concentration of the solution? Because the question tells me that I'm only adding water to my solution, this is a dilution question, and I'm going to start with C1V1 equals C2V2. Now you can plug in any units for C1 and V1. You don't have to convert the volumes into mils, and you don't have to have the concentrations in moles per liter. It could be in M to M percentage, ppb, whatever works, as long as the units that you sub in for the one side are the same units that you sub in for the two side. Let's sub in what we know in this question. The initial concentration is going to be 12 moles per liter, and my initial volume is 25 mils. I want to know what the final concentration is. That's C2. If the final volume is 150 mils. When I rearrange for C2, it's going to equal 12 times 25 divided by 150. I have to get rid of this 150 on this side. That equals 2.0 moles per liter of HCl once I take my sig digs into account. Try out example 2 on your own. Pause the video here until you have your answer. Here's the answer for example 2. You need to make 2.00 liters of a 0.500 mole per liter HCl solution for a class experiment. What volume of 12.0 moles per liter stock solution do you need? 12 mole per liter is pretty standard for buying hydrochloric acid solutions. Because I have a stock solution and I'm looking for a concentration that's lower, I'm going to dilute this solution and use C1V1 equals C2V2. Let's plug in what I know. My initial concentration is 12 moles per liter, and the question asks me how much of it do I need, so I'm looking for V1. The final concentration that I want to make is 0.500, and I want to make 2 liters of it. Do the math and rearrange for V1. Now this volume comes out in liters. Because I subbed in liters for V2, V1 will also be in liters. I need to have 3 sig digs in my answer. Now if that number doesn't make sense, you could always divide it by 1,000 and convert it into mils. So in order to make 2 liters of 0.500 mole per liter, I take 83.3 mils of 12 molar hydrochloric acid and add enough water in order for my final volume to be 2 liters. Try out the preparing solution questions listed on your assignment cover sheet.